Hey guys, welcome back. We're doing example number 2 now. It's a very short example where it's actually asking us to find the distance between two matrices. So the first thing that we're going to do here is look at the equation that's given to us. It's just the magnitude or the norm of our subtraction of our two matrices. This is very similar to something you guys did back in multivariable where you were trying to find maybe the vector length between 2 points. And what you do here is you would find the vector would be the difference between b and a, right? You subtract b minus a, and then you would find the magnitude of that. So that's exactly what this is right here. Instead of having points a and b, we actually have matrices u and v. It does not matter the order that we choose. So all we simply have to do is just find the difference of those two things and then just find the length of that difference. So it doesn't matter if it's u minus v or v minus u. So we're going to go ahead and just do what the equation says here. We're going to do u minus v. Because remember, guys, we're going to square these numbers in the end. So again, 1 minus -2 or -2 minus 1 will not matter. So we're going to go ahead and do u minus v. And so in the previous example, it's just going to be 1 minus -2. So I'm just going to go ahead and write down that that's actually going to end up being 3. Then it's going to be 3 minus 1, which is going to give us a 2. -3 minus 0 is going to give us -3. 4 minus 4 is going to give us 0. And then 0 minus 3 is going to give us -3. So pretty simple stuff here. And then all we have to do is take the norm of it, or the length of it, or the magnitude of it, whatever you want to call it. All right, so let's do that. Well, we've done that actually in the first example as well. We decided that we take our components of 3 and we square it. We add 2 squared. We do -3 squared. Obviously, 0 squared is 0, but we'll put that down as well. And then -3 squared as well. So again, we're just finding the difference of our two vectors. And we get that this ends up being the square root of 31. So very easy thing for us to do. Okay, so I'm going to go ahead and shift down here to example number 3, where it's now going to ask us determine whether the given vectors are orthogonal to each other. And so if you guys look at the notes that's given to you, that's provided to you here, in order for two vectors to be orthogonal, there's a couple things that we have to remember about that. Remembering that for vectors, something's orthogonal, that means that they have a dot product that is actually 0. So that's what we're going to use for this. This is the simplest way to do this. There's other ways to do it per your notes, where you can find the magnitudes of the functions, but we're just going to do the dot product of u and v. So that's what we'll do. And so basically we're going to do the dot product and see, is it 0? If it is, they're orthogonal to each other. If it's not, then clearly they're not. So very quickly, we're going to do -1 times 4. And then you get -3 times 2. And then you're going to add 2 times -1. And we're going to get -4, +6, -2. So since our dot product of uv is actually equal to 0, then we can say that yes, u and v are orthogonal. Okay. Similarly, if you do, what happens when we dot something to our 0 vector, right? So anything that we do here, you're going to obviously see that u sub 1 times 0, that's obviously going to be 0. U sub 2 times 0 will also be 0, and then u sub 3 times 0 will also be 0. So what can we say about that? Well, obviously it's going to be orthogonal, but we can say that the 0 vector is always orthogonal to all vectors, every single one of them. Because when you dot this with 0 vector, you're obviously going to get 0. All right. And then our last example to finish this part out is looking at whether this u and v is orthogonal. So we get 0 times 5, which gives us 0. 3 times 2, we're going to add that to -2, -1. And then we're going to add that to 1, 0. And when we do this, we are going to get that 0 plus 6 plus 2 plus 0 is actually giving you a value of 8. So in this case here, no, u and v are not orthogonal to each other because, again, the dot product has to be equal to 0. So again, very simple stuff that you did back in multivariable, and this is where we'll finish this video for this one. I will see you guys back in the next video.